Yeah, we're really interested, especially since we live in North Carolina, and North Carolina has a lot of known sources for PFAS. We want to make sure that our environment is being taken care of and that we know what we're being exposed to. So I guess be living in the same area as known sources, but also knowing that it's ubiquitous and it gets throughout the world, even if you aren't living in it, I think it's important to study.
Mm. So I this article will be going out to students
Okay.
like me, and I just want to know very simply, what is your definition of forever chemicals like PFAS?
Yeah. So, PFAS it's a very big group of chemicals. So, the OECD, which is an organization out of Europe, defines it as any molecule that has a CF2 group or a CF3 group at the end of the molecule. So, anything that has this carbon with the two fluorines or carbon with the three fluorines. So if you go to PubChem, which is the list of all known chemicals, there's about 119 million in there. 7 million of those are actually fall under this OECD definition of PFAS.
Hmm.
And so it's really big, but the EPA and several of the regulating industries are really worried about the chemicals that are heavily fluorinated, so have even more fluorines usually than this definition says, and then might be longer carbon chains, but there's also interest in shorter carbon chains now too. So yeah, it just kind of goes back and forth to what they characterize as important. But the EPA has about a list of about 14,000 PFAS that they think we should be concerned about.
And so with PFAS and this concern, what are the major, because I understand that some of your students in the Baker research are studying blood and how it gets into humans externally. What are the major concerns that scientists are seeing and you alike are seeing with PFAS?
Yeah, so our big concern is just how prevalent it is, and it keeps popping up in all kinds of different samples we're looking at. So we see it in some of our environmental samples with water and air, and then the foods that we're taking or the drinking. So like we see it heavily in fish, some fish samples, and some of the ocean, like mussels and clams and things like that. So some of the shellfish. And then we are doing some of these clinical assays of blood, and we're seeing certain PFAS in the blood that are basically moving around your body a lot, and then ones that people didn't even know existed in the environment we're seeing in the blood. So that's a little alarming too.
Do we have any indicators of any diseases that it could be causing right now or in the future?
So one of the PFAS, and it's PFOA, has already been termed a group 1 carcinogen. So it's
Mm.
uh, like a whole committee went through and termed it as a group. And there's another one, PFOS, is a group 2. It's either group 2A or B. Let me look. Um, group 2. Group 2B. So it's determined as possibly carcinogenic to humans, but a majority of the other PFAS don't have any toxicology information. And so since they're sorting through these and finding them as either carcinogenic or potential carcinogens, that's what we want to make a list of things we're seeing in people so that more toxicology information becomes available so we know whether they do have cancer links. But there are different areas where PFAS have been known to accumulate, and a lot of times they see trends with the people in those areas of like high levels of cancer or specific conditions that they're linking to different PFAS.
I'm just curious, has your research or your research groups seen anything with any linkages so far, or?
So we're not doing a specific comparison between
Hmm.
cancer or not. We're getting samples from like people around North Carolina and then just seeing which PFAS we see in the blood for different people. So then like maybe we could say if there's a point source or ge a geographical area where we are seeing higher levels of cancer if we do see higher levels of PFAS in those areas.
Okay.
So
Now,
yeah, we're doing like I guess the first step, and then the next step is to
yeah.
see if there's correlations.
So is as you've explored this topic, are there any popular methods of prevention or steps that we could be taking to decrease the intake?
Yeah, so right now PFAS are in fast food containers, and so that's one scary area. Some people are taking their own containers to take for fast food. Some other things are drinking water. So we're seeing certain communities have been exposed through drinking water. So filtering your drinking water, I think, is really important so you don't end up being an accidental exposure group. So those are kind of some of the others. Then people are looking at where PFAS are in like different companies. So like Scotchgard, Gore-Tex, some of those, and trying to, if they need products of those type, like if you need a rainproof boot, um, trying to find ones where they're not using PFAS for the rainproofing and um, yeah, supporting those companies. I think Starbucks is trying to take it out of all of their like bread sleeves and things that they give you when you're leaving. So I think that's kind of the main thing is people are looking at where the main sources are and seeing if they can eliminate or reduce those in their daily lives.
Yeah, because as I've been looking into it, a lot of private wells are, specifically in Moore County, there's a high concentration near a landfill,
Yeah.
as originally, and there's 21 private wells around the area, and I'm just more concerned about these more rural areas
Yeah.
and how what we can be doing to test those areas and maybe prevent those citizens from being exposed, if that makes
Yeah,
sense.
I think the biggest thing is just filtering their drinking water right now because if once the PFAS are in the wells, it's pretty hard to get them out of the wells. And uh, so like just making sure that you're filtering out with a filter and that you make sure to replace that filter when you think it's saturated with PFAS. But then the scary thing is basically then that filter goes back into the landfill and leaches out PFAS because there's not a good disposal program. The best thing they're doing, some of the chemical companies are they're incinerating the PFAS, so they just bake them really, really hot because PFAS are, some of them are very thermally stable. But a lot of the filtering collections aren't taking the filters for incineration currently. But yeah, so we kind of have a dirty cycle of like, even if you
Yeah.
do filter out your drinking water, then you send your filter to the landfill and then it leaches out again. And so you're just putting more PFAS back into the water sources.
S- that's interesting. I didn't know about the incineration part of this. Thank you. So I guess as
Because
we
oh, sorry, I guess that, so,
sorry.
yeah, so, yeah, because that's the one problem with PFAS is like they don't UV degrade because like if you use them in your cookware and you heat up your pan to super high temperatures, they have to be UV stable. Most of them are pretty UV stable.
All right. So what I did see this thing talking about uh, PFOA and PFOS
Hmm.
being sort of slowly coming out of our systems, or at least they're becoming something older, and new PFAS chemicals are showing up more frequently.
Yeah.
Can you tell me what that is exactly? Why older chemicals are coming out, but newer ones are coming in at faster rates, or what, in that field?
Yeah, it's mainly due to the different industries. And so in the late 1900s, 1900s, 1980s, 1990s, they started seeing links between people that were working with these chemicals and diseases. And so people at different plants um, working with the chemicals were getting sick. And so a lot of the industries actually voluntarily started phasing out PFOA and PFAS, which are two of the legacy PFAS that they were seeing these connections with. But everybody loves the properties of PFAS, so everybody likes this grease resistant and water resistant. So then they basically said, can we make other chemicals that will have similar properties but different chemical structure? And so that's why these emerging PFAS are starting to shoot up now, and the other ones are dropping, is they were phasing those out but making these. But even the ones they're phasing out, some of the other PFAS are either degrading into those, or there's so much in our systems that we still keep seeing them pop up over and over too.
That's
Yeah,
surprising.
sad,
It's yeah.
disappointing.
Um, I guess as we end this out, and again, once again, thank you. What's next? Like overall, in your field and what other colleagues are doing, so what's next for studying PFAS and trying to build more prevention for it?
Yeah, so right now we're actually working with a few remediation companies to try and see if certain techniques that they're doing will actually help eliminate some of these longer carbon chains. And so that's our goal, is like we can see it everywhere. And so my students actually were kind of discouraged of like, I can analyze anything and I can find PFAS in it. But now we want to see if we can work with these companies and see if there's ways to actually break it down or get rid of it. I
Okay.
think the other, oh, sorry, I think the other thing is just in like Starbucks and some of those other big companies taking responsibility and getting it out of their products. So there are certain areas we still need PFAS, like in firefighting gear, they haven't found anything that's as thermally stable as PFAS. And so when they take it out, then the gear catches on fire, and we don't want people in those jobs to walk into
Yeah.
a fire and burn. Um, but do we really need it in fast food containers just so our hands don't get greasy? So
Yeah.
we kind of need to decide where it's a necessity and where it's just a luxury.
That makes sense. It's a troubling issue.
Yeah.
Well, I thank you for spending a little bit of your time to come out and talk to me.